8.5, the algebra of matrices. An m by n matrix has m rows and n columns, so its dimension is m by n. And then each individual entry is called, or number is called an entry. So equality of matrices, matrix A and matrix B are equal if and only if they have the same dimension m by n and corresponding entries are equal. So every spot in A is the same as the spot in B. We can add two matrices or subtract them if they have the same dimension. And they add or subtract by the corresponding spots. We can use a scalar product where C is our scalar and multiply matrix A and an m by n matrix. It comes out the same size. So we have matrix A, which is 2, negative 3, 0, 5, 7, negative 1/2. This is a 3 by 2. We have matrix B, 1, 0, negative 3, 1, 2, 2, which is also a 3 by 2. We have matrix C, 7, negative 3, 0, 0, 1, 5, which is a 2 by 3. And matrix D, 6, 0, negative 6, 8, 1, 9, which is a 2 by 3. So we're known to perform the indicated operation or explain why it cannot be performed. So we're known to, for part A, we're known to add A plus B. So we write 2, negative 3, 0, 5, 7, negative 1/2. Add to it B. And we add by spot position in the matrix. 2 and 1 goes to 3. Negative 3, 0 is negative 3. 0, negative 3 is negative 3. 5, 1 is 6. 7, 2 is 9. Negative 1/2 and 2 is 1.5, or 3/2. C minus D for B. So we have matrix C minus matrix D. And now we just have to subtract the second number. So 7 minus 6 is 1. Negative 3 minus 0 is negative 3. 0 minus negative 6 is positive 6. 0 minus 8 is negative 8. 1 minus 1 is 0. 5 minus 9 is negative 4. Part C is having us add C plus A. But when we look at it, C is a 2 by 3, and 3 is a 3 by 2. These are not the same, so they cannot be combined. Due to different sizes, different dimensions. That just leaves us with part D, 5 times A. So 5 is our scalar. What a scalar does is it multiplies everything that's in your matrix. So it's kind of like distributing into the matrix. So we get 5 times 2, 10. 5 times negative 3 is negative 15. 0 times 5 is 0. 5 times 5 is 25. 5 times 7 is 35. That should be a 2. And 5 times negative 1/2 is negative 5/2. So now we're going to learn how to do matrix multiplication. It can be written AB or A times B. it's only defined when the number of columns in A is equal to the number of rows in B. So, columns in A, rows in B must be the same. And your outcome has an M by K. So the way we multiply them is called inner product. It's where you take a row of A times a column of B. So if you have a row of A, and if we have our column of B, their inner product is the number of all those little ones multiplied, added together. So it's really better to see an example. It will produce a new matrix. So we have matrix A, which is a 2 by 2, 1, 3, negative 1, 0. We have matrix B, negative 1, 5, 2, 0, 4, 7, which is a 2 by 3. We are first going to find AB, which is a 2 by 2 times a 2 by 3. And you see that it matches up the same in the middle. So, let's start by writing our matrices. A times B. So we are going to take our first column of A, first row of A, and times it by our first column of B. So A1 times B1. And this is going to give us a spot, C1. So we got 1 times negative 1 plus 3 times 0 goes to negative 1 plus 0, which is negative 1. So our output matrix, matrix C, has an upper left spot of negative 1. Now we are going to take our A1 times our second column, B2, to get C2. So 1 times 5 plus 3 times 4 gives 5 plus 12, which is 17. Now we got to find our C3. I guess this is C11, C12, C13. So we're going to take our A1 times our B3. 1 times 2 plus 3 times 7. 1 times 2 is 2. 3 times 7 is 21, so 23. We are expecting to get out a 2 by 3 matrix. So we got our first row. Now we got to use our second row in matrix A, negative 1, 0, and find the other spots. So C2, 1 is going to be A2 times B1. Negative 1 times negative 1 plus 0 times 0 goes to 1. C22 is A2 times B2. Negative 1 times 5 plus 0 times 4 becomes negative 5. And C23, that is our A2 times C3, sorry, B3. goes to -1 times 2 plus 0 times 7 to get -2. So now we have completed our matrix C. Now let's look at B times A. B is -152,047 times 1, 3, -1, 0. When we look at the size of these, this is a 2 by 3, but this is a 2 by 2. The 2 and the 3 do not match up, so this is not defined. You cannot do it because they are not the same size. One thing about matrices and multiplication is that it is not commutative. When both AB and BA are defined, they are not necessarily equal. So we're going to run through a quick example of that. We have A, we have B. So let's find AB. They are both 2 by 2, so our output is going to be a 2 by 2 as well. So for spot C1, 1, take row 1 times column 1. So 5 times 1 plus 7 times 9. That gives us 68. For C1, 2, we take 5 times 2 plus 7 times -1. We get 3. Now for row 2, C2, 1, take our second row, -3, 0 times our first column. -3 times 1 plus 0 times 9 gives us -3. And C2, 2, -3 times 2 plus 0 times -1 gives us -6. So AB is a matrix 68, 3, -3, -6. Now let's find BA and see if the same thing comes out. So now we are taking 1, 2, 9, -1, and we are timesing it by 5, 7, -3, 0. So 2 by 2 times 2 by 2 will give us an output of a 2 by 2. C1, 1, first row, 1, 2 times first column, 5, -3. Gives us -1. C1, 2, 1 times 7 plus 2 times 0 is 7. Now C2, 1 goes 9 times 5 plus -1 times -3 goes to 48. And lastly, C2, 2 goes to 9 times 7 plus -1 times 0, 63. So comparing our two outcome matrices, they are not the same. So please remember, it is not commutative. Matrices have the following properties when they are being multiplied. A times BC is the same as AB times C. A times parentheses B plus C is the same thing as AB plus AC. And B plus C times A is the same as BA plus CA. But please remember, AB is not the same as BA, so you cannot switch the order. So we have the following matrices. And a few operations to perform. So our first request is for C. So we take C, we are multiplying it by scalar 4. 4 times 5, 36. That goes to 20, 12, and 24. Our next request is A times D. Let's first look at the size. A is a 3 by 3. D is a 3 by 1. So we can do this, and our outcome will be a 3 by 1. So we are starting with 5, 9, 2, 1, 7, 6, 3, 4, 8. We are going to multiply it by 4, 8, 1. So this one's going to be a little bit easier. We got 5 times 4 plus 9 times 8 plus 2 times 1. That all goes to 94. For our next row, 176, we go 1 times 4 plus 7 times 8 plus 6 times 1, and that goes to 66. For our last row times column, 3 times 4 plus 4 times 8 plus 8 times 1, and that goes to 52. 3CB. Now, nothing is grouped, so let's just go in order from left to right. So we need to take 3C. So 3C is 3 times 5, that is 15. 3 times 3 is 9. And 3 times 6 is 18. So we got our 3C. And now we're going to multiply it by B. B is 9, 1, 6, 7, 2, 4, 8, 10, 3. So let's first see if it matches up. This is a 1 times 3. This is a 3 times 3. So our outcome will be a 1 times 3. So let's get us some more space. We're going to take 15, 9, 18 times our first column. And then add those all together. We get 342. Please use a calculator if you need to. First row times second column, 15 times 9, 15 times 1, plus 9 times 2, plus 18 times 10. This becomes 213, and first column times the last, first row times the last column. 15 times 6, 9 times 4, 18 times 3. And that becomes 180. So we got our output matrix of 342, 213, and 180. So our last one is C times A plus B. Now looking at them, A and B are 3 by 3, and C is a 1 by 3. It's going to be easier to add the A plus B and then multiply by C. So let's add A plus B. We're going to get out a 3 by 3. And we are going to get out 14, 10, 8, 8, 9, 10, 11, 14, 11. Now we're going to take A plus B, which we just did, and multiply it by scalar, C. 5, 3, 6. So we have 5 times 14 plus 3 times 8 plus 6 times 11. That goes 160. 5 times 10 plus 3 times 9 plus 6 times 14 goes 161. And 5 times 8 plus 3 times 10 plus 6 times 11. That goes to 136.